Hey, what's going on, folks? It's Mike here, and welcome back to my Programming Language First Impression series, a series in which we take a look at a programming language for the first time for about an hour or so and just uncover or explore some of its features. And the purpose isn't to say that this language is better or must be used versus some other language, but it's just to see the different trade-offs that different languages made and look at different fun projects and experience it as a beginner would. So today's programming language that I want to go ahead and investigate, I'm actually going to go to a YouTube video that I'm briefly going to play here. And this is courtesy of Digital Foundry here, and it's a documentary that they did recently inside Penny's Big Breakaway, where it's going into a deep dive here. And I'd really recommend this video. I'm going to link it below because I was watching it and fascinated, and I found our programming language for today, the Beef programming language. I'm going to be curious if we can find out where the name is here, but basically they use this programming language in this game here. I'll just kind of flip through it and you can see what the game looks like. It looks awesome here. These are some of the developer screenshots. Let's find the actual gameplay here if we go later in here. So it looks like a super fun game, and this was built in the Beef programming language. So I thought this was really cool and that there were some neat things just visually going on, and of course to build this sort of type of beautiful game with animations and lots of polygons and gameplay and all sorts of stuff going on, the language must be interesting. So let's go ahead and check out the Beef programming language here. So I'm going to go ahead and just open up the main page here. We'll probably look at the GitHub here and try to build it. But I found this interesting Hacker News post here. So I just wanted to click on it here. And basically, it was posted here, and this was in January 8th of 2020. And basically I see the author here, I guess Beef Dev here, saying, "I'm the engineering co-founder of PopCap Games. They left PopCap Games after the EA acquisition. And their thoughts were that before Beef, I was developing game code in C# and engine code in C++, and I felt C# was just much more pleasant to work with. And I think a lot of folks, C# really is a nice language. It probably gets hidden in some ways, and it's probably a language, if you'd like to see on this series, that we should take a look at. I haven't programmed C# in quite some time, but it's one of the first languages that I use professionally, because I did really enjoy the fast compile times. I was using it with Visual Studio, which was really nice IDE. I'm sure it still really is. And again, you can typically get better errors in C# type of languages versus other languages. So then it struck me, again, none of these things I really liked about C# really had anything to do with the JIT or the GC. It may be possible to create a best of merging between C# and C++. So we're going to open up this forward here. Maybe that's the place to actually start with the language. And again, you can look at this Hacker News. Maybe there's small ideas or conversations there. I didn't read through the whole thing, but I just saw that the dev, one of the devs at least, was up there, which is really neat here. So let's kind of explore this language. All I know is that this language exists. It was used in that YouTube video, which I really liked. So anyways, I thought it would be perfect to explore here because I'm really, really curious about the language. So from a first impression, Beef is a high-performance, multi-paradigm, open-source programming language with a focus on developer productivity. Okay, so I like those things. I like high performance. I like developer productivity. I like that it's open source, so you can modify it, change it, do whatever you want here. And I think this is really interesting. So Tier 1 platforms, IDE, and binary. So it sort of supports Windows, I guess, by default here, which makes sense if you're doing game dev and these types of things, right? We'll have to look at inside Penny's Big Breakaway, or Penny's Big Breakaway, the game more. I don't know if it's Windows only or what's the story, but it looks like this language is also supporting, the other desktop operating systems, including WASM for WebAssembly. And this was really intriguing here to see Android, Nintendo Switch, PS5, Xbox Series X. So, clearly for the gaming, graphics, game engine scene, and so on, that has my interest because beyond programming and software engineering stuff, right, on this channel, we do a lot of graphics programming things. So this is kind of neat here. Again, just as a first impression here, let's view some example source code maybe, and we can play a game here. Oh, mscripten generated. So let's go ahead and have this. Yeah, this is quite nice here. Let's see how we do here. Oh, all right. But, already kind of a cool little demo application here. I'm not going to spend too much time in here. Let's just go ahead and crash here. A few times here, but nice kind of game here. If I go to view source code, it takes me to this nice project here for the space game example. Okay, so it's using SDL2 library, which SDL2, I know you can use a library called mscripten, which let me bring in another window here, mscripten, in case you haven't seen that. Basically, that's let's go ahead and actually just look at this project here. A complete compiler toolchain to WebAssembly using LLVM with a special focus on speed, size, and the web platform. So compile your existing projects written in C or C++ or any language that uses LLVM to browsers, Node, or WASM here. So again, if you haven't seen this, it's a really cool project. And I know it has special support for things like the simple direct media layer, which again, you can check out and search on my channel. We've got a lot of SDL videos otherwise there. So, maybe we should just like dive into some source here. Let's see if we have like a main program or something here. Yeah, this looks like a main here. And it's giving, well, I guess there's like maybe an IDE or something if we just press F5. So we'll have to try to maybe build the beef programming language here. But this is looking kind of, yeah, C#-y. Maybe it's object oriented, and then we have like our public static void main function here, capital main here. That's neat. And then some of these functions for our game app here. Okay, so interesting. Yeah, pre-initialize, initialize, and then run the game app here. Let's see if we can just jump to run. Okay, so we should look for like game app or something maybe. Yeah, game app.bf for beef. And let's see. Oh, this is kind of interesting. I've seen this in the D programming language where you have like static blocks, like module constructors, basically. So I don't know if this is using a module system. Has some stuff that I sort of remember from C#, like using which libraries here. Yeah, you've got your namespaces. Well, this is kind of nice. I guess it just puts everything maybe in this space game namespace, so that's kind of neat. And then we have static, which again, this idea of like a module or a static constructor. I didn't see any header files or interface things here. But this would be, I suspect, executed before any of like the code here. And that's kind of important just so you have some way to like construct objects if you are going to have global objects, that they sort of live in a nice space here. But anyways, here's our game app. Let's go ahead and see. Yeah, this is looking pretty like C++ and C#E mixed. So I've got a class here that's inheriting from the SDL app, I guess. Hopefully I'm reading that right here. And then we've got like, yeah, some of these things that look like C#, the same like wicket, or between the angle brackets here. The type here, I could do a new list here. I mean, that's kind of cool here. I mean, we should look at this. So this is telling how I'm going to initialize this. I guess I don't have to write a constructor. It just initializes this and tells me that I'm going to allocate this. This is kind of interesting. Tilde, delete container items. Huh. Okay, so I'll have to think about that. I wonder if that's like how to construct it and how to destruct it. Okay, so that's kind of interesting. We'll have to really look at this language, and it's focused on game programming, as it mentioned. So I just want to take a look at this. I like these things that, again, that I'm used to in like the D programming language for your constructor and destructor just being this instead of like if I rename this class or something, which I frequently do, at least when I'm starting code. It's kind of nice to just not have to change all these constructors here. Okay, but we've got like some of the override stuff and so on. These functions with types, so maybe it's statically typed. We're doing this review kind of backwards than we do sometimes, just reading source code. Again, we've done enough of these. It's kind of nice to just jump in here and be able to see things. Again, this is a C-like language here. So these are looking pretty nice here. A lot of void functions. All right, so looks pretty good. That's a space game, but let's jump back here and try to learn a little bit about the language and actually building it. I do want to try to build it from source code. I think we could probably just dive into the GitHub repository. Let's just clone this and get this process started just so we have something and ready to go. Because again, the tier 1 platforms, I guess, are Windows and so on. Okay, I already have beef. Yeah, let me remove that. I think I tried to download this before, but let's download it again. Let's do a build from source here. Let's see what we got here. So let's cd into the beef directory. And of course we've got this builds. Okay, so that's empty holder. Okay. Yeah, so I looked at this. There is one dependency. I did actually try to build this from source previously, but I needed LLVM 18.1 or later here. I'm just going to make a directory called build inside here. I don't know if it's going to like that. And let's just do cmake, and then I'll look up a directory so I can find this cmake list here. Let's see. Okay, so it says LLVM cannot be found here. Okay, let's see here if I can do this properly. CMake warning. Could not find a configuration file for package LLVM that's compatible with the requested version. Okay, I guess it needs 18.1 specifically. Yeah, I have version 20 here. I wonder if I can just change that. Will it be happy? Let's see if I can do that. Okay, I'll just have to search around here a little bit. Let's go to the Beef programming language. Let's see here. Let's just go to the documentation here. I just want to get that build started here. Getting started, install. Building from source. Here we go. Okay. Building from source is not required on all platforms. Yeah, okay. So a lot of these binaries are already in Windows. Okay. Oh, these are the build steps. Okay, it's first going to download and build LLVM. Okay. And if you just saw one of my recent videos, I showed how to build LLVM 20 from scratch. That's what I have available here. Okay, I just sort of read the instructions. Build beef. Okay, go into bin and then build sh. Let's see if it just works here. We can get this kick-started in the background here. Okay, so let me remove that build directory that I made here. I'm going to go into bin. Oh, I should just run / bin. What was it? sh. Okay, let's just see if it runs here and that script is executable. Bin build.sh. Okay, there's an iOS thing here. Okay. Starting build. Okay, it's building. Ninja is enabled for this build. Okay, error. LLVM 18.1 is not detected in your system. Please install this package to try again. Okay, sudo apt-get install. Interesting, it doesn't work with a newer version. But let's see if this works here. Okay, unable to find this package. Let's see if we can find it. It's probably like lib LLVM or something. Let's see. Let's see. Apt cache search LLVM 18 dev. Oops. Gotta spell search right. Search apt. Oh, apt search. Sorry. Let's see here. LLVM 18. Maybe it's LLVM 18. LLVM. All right, let's try that here. Let's see here. LLVM. Okay, 15. LLVM-dev. Well, we know we need version 18 here. Let's see here. Just scrolling. Okay, version 12. Okay, lib LLVM here. Okay, so I need to find some I guess I need to update my package manager or something. I'm on this version of Ubuntu for those of you who are keeping track. So I am going to try to cheat a little bit here. I found this question here. Okay, I should be able to do wget, make it script executable, and then I can install a specific version here. I wonder if this is going to give me the dev version, but let's see. That should be okay here. Okay, so maybe this is like a trivial thing that I should just know. Let's go ahead and put that in here. Let's see here. Give that a try here. Okay, I got my shell script. Let's make it executable. Okay, fine. Version 18. I wonder if it's going to build it from source here. That could take a while here. That's why I want to get this process started. Okay, and then I'll try to run it here. That's going to be the Clang compilers, but I don't know if I'll get LLVM 18 specifically, which does take forever to build. Okay, so let's see if we have that available here. Let's see. Anyways, let's go ahead and just take a look at the language here while that's installing, and we'll give this another try. Okay, so interesting things here. I'm already intrigued with the language here because it supports many different platforms that we don't usually see here. Now, I guess if you're building on LLVM, again, that framework, basically supports all these platforms, which is really, really cool here. I like that it is clear what their sort of target is. And again, we saw the Hacker News post here that shows that it was a game developer sort of doing these things here. But let's look at the language features here. So C and C++ interop with static and dynamic libraries, custom allocators, batched allocators. Okay, so these are like game dev things that we care about, especially on the engine side, which is pretty cool. Compile time function evaluation, love that. Compile time code generation, so very, very powerful. Tagged unions or variants, generics, tuples, reflection. I wonder if that's static and dynamic reflection. That's pretty cool. Again, it's been a while since I've touched C#, but I know languages like Java and C# have good reflection engines, or at least JIT compiled languages tend to have very good reflection on both the static and the dynamic side. So we've got lambdas, defer statements, which is really, really cool. That's something that I like. We saw that in Odin way, way back in the day, in the V language and so on, which basically allows you to write functions that are deferred for execution for later. So no problem there. We've got SIMD support for single instruction, multiple data, so no problem there. Type aliases, extensions, pattern matching, oh, that's cool. Or ranges, string interpolation. So, I mean, this is hitting some of the like new things here. String interpolation, ranges, pattern matching that you expect in sort of C-like languages to have. I know these things have been around forever in functional languages, but that's kind of cool. Argument cascades, I'll need to see an example of that. I like mix-ins or template mix-ins, again, things from D that I've learned. Custom attributes, operator overloading, namespaces, bit sets. Cool, yeah, a lot of people forget about bit sets. These are like super important in games here for just having like really small pieces of data. A literal set that's using ones and zeros to tell you if something's in the set. Atomics, I mean, this is all cool stuff. Dynamic foreign function interface, guaranteed inlining, that's good. So I guess it's forcing inline, which some folks might have used in GCC. In languages like C++, for instance, when you use inline, it's not necessarily a guarantee. It's just sort of a suggestion to a compiler, but you can use like compiler intrinsics to force these things. Incremental compilation sounds like something super, super important for game dev stuff because these builds get really big. And built-in testing, I like that. This is something that we've probably never seen on this series. I think that's maybe that's not 100% true. Maybe there was like a supported IDE here. Let's zoom in on this here. There's a custom IDE here. That's really cool with a general purpose debugger. I wonder if the debugger too was built from scratch. So I'm already like intrigued on this. I like this to have an official debugger with a language if I'm building something from source here. Really, really cool. Let's see. So the IDE itself has like fixits. Okay, so these are things coming from LLVM. I see why I need to download LLVM here. We've got reformatting, refactoring tools, compilation, built-in profilers. Okay, all good stuff here. We got mixed builds. So I can safely mix different optimization levels. Oh, that's kind of cool on a per type or method level. Okay, that's kind of cool. So I can like pick maybe a module or something and hyper optimize it because it's a hot path of code, but maybe I don't care about like a user script or something. I see. So we want to be able to just, maybe if we're just working on one module, have everything be like super fast. And then the one module that we're like, hey, this is the new code that I haven't tested, be able to just debug that. So that's kind of cool. I guess that's saying since we have sort of these units or maybe modules that we can compile with different levels of debugging. So that's cool. Let's see, real-time leak detection. That's cool. So I guess maybe I don't need to use Valgrind or something. Yeah, really neat here. Okay, so we got a lot of releases here. I wonder if there's just a nightly release. Oh, that's for Windows only, maybe. Okay, that's okay. Let's see how we did here. Okay, so we got LLVM. No, well, we got the Clang 18 compilers. I don't know if we got LLVM with this, though. Let's see here. Let's see. So I was going to try to do /bin build sh here. Let's see if that did the trick here. It's going. Okay, cool. So that was a lot simpler. Okay, so it looks like it found my LLVM 18 here. Okay, cool. Not a bad setup then if you need to just run that LLVM script here. Since I am on Linux, I'm on the second tier again in this programming language as far as the support here, but I'm really impressed with some of these things here. I don't know if I'm getting the IDE when I build it. I don't know if it matters, but I think that would be really cool. I think that is a cool thing that we have here. So let's check out a few things here. How active is the community? Okay, we got a Reddit page here, Discord, and a community managed list of frameworks, libraries, and resources. Cool. Let's check that out here. Okay, nice. Yeah, we just got the full list here. So I'm sure folks can add pull requests and add stuff here. Okay, yeah, we got the game dev stuff. Some different engines, lots of libraries. Okay, very cool. Yeah, you got your standards here like I'm GUI and so on for game dev, some graphics engines, Vulkan bindings, and so on. Yeah, pretty cool here. Let's go ahead back here. We'll look at the language here in a moment if it after we get a successful build. Okay, we got Doxygen here. Okay, auto-generated Doxygen page here. Let's see, we got our classes. What am I looking at here? Okay, I guess our core library here. Okay, you got all the types here. What's an array 3? I just want to kind of look at the documentation. 3-dimensional array here. Okay, reasonable enough to look at. No problems. You can see kind of easily what's going on here, so no problem there. Let's see. This looks like it's building. Yeah, we're getting some warnings, but no problem there. All right, almost linked here, so it doesn't take too long. Let's get out of here, out of the Doxygen page here. The releases. I do kind of want to see what are the nightly releases. Okay, I just got the binary set up here. Yeah, it's too bad. If the build fails, I'll re-record this on like a Windows machine or something. But you got an installer here, release notes, 2022 here. So maybe it's pretty stable. Let's see what the sort of cadence is here. Yeah, there are various. I mean, it's a relatively young project here. Again, we've looked at most programming languages that are years and years old, but that's kind of neat here. I'll be curious. To see other projects that sort of take this on here. Let's see. Okay, we got the contact community and so on. Let's go to this forward here, which we found from the Hacker News page here. I'll just kind of read about this just a little bit here. Oh, cool. It ran a bunch of the tests here. So it looks like we've got things up and running here. I just want to check and see if I go into the bin directory. Okay, it gave me a bunch of stuff here, a bunch of things here, and we'll figure out how to run this here. So let's just make sure that we have a build. So built from source, and then I guess I can go into the language guide. Okay, so they're doing some interesting linker stuff here. I just want to find like the hello world, which I think was on the web page here. Yeah, let's just compile this. Let's just make sure that we got a working install here. Now, where is my compiler here? How do I get this thing working here? Let's see. Is it in builds? Folder. Let's see, I got the beef boot here. What is that here? Okay, those are the projects there. Beef build. I wonder if that's a build tool here. Debug, Linux. What do I got here? Some of the libraries. Let's see if I read the README page here, if I get to something here. Back here. I've got these shell script files here, which I'm assuming the build sh just runs here. Let me go back here. Let's go back into the README. Take a look here. Binaries, documentation, design goals. Okay, that's where we are in the forward. That's what we're going to read. Oh, we got the IDE here. Did that build it? Again, it's hard to know. Would it be in the distribution? What is beef build D? Okay. Let's see here. Let me just go to the high-level directory here and see if I can figure something out. Okay, so let's go ahead back. I think I was close. I'll bring in the directions here. After building from source here, it looks like it says the build results will be an IDE distribution here. So it looks like I was close here. So IDE, the distribution here. I'm guessing it is just beef build. Okay, yeah, and okay, use the new command line argument to create a new workspace. Oops, help. Okay, There we go. Okay, if no arguments are specified, a build will occur using current working directory as the workspace. Okay, so I guess I need a workspace or something. I guess for now I could probably just use -run here. And I did see it looks like the IDE is only available on Windows right now, which is fine here. Can I just do run like file bf or something? Let's see here. Unhandled command line. Let's see if it just has like file not found here. Hello.bf. Unhandled command line parameter. Okay. Compile and run the startup project in the workspace here. Generate. Oh, okay. Here we go. Generate startup code for an empty project. Okay. Beef d generate. Let's see what it does here. Air workspace b space. Okay. So new and then generate maybe. Okay. And what did it do here? Beef space here. Did it make a folder? I don't really care if it made a folder. I just want to try this out here. Let's see here. New workspace. So this might. I'm guessing nobody uses this document. Oh, I guess there's like a folder for like a build or something. Let's see here. Or is this something totally different here? What is this here? Yeah, let's get back here. So I'm guessing no one really uses the command line interface for this. Let's see. Can I do -run? Okay, so it's running my project wherever it is. Just need to be able to find it here. Let's go up a directory here. Oh, actually, you know what? Let's go into here. Oh, here's like a beef space thing here. So I wonder if that's like a for the ID or something. Test here. And let's go back, do beef build, and do new. Okay, so that gives us our new thing here. And then generate. Okay. Okay, and that gives us our source here. So now we're on to something. Vim source. And we got our program. Cool. And then if I do tree for our build. Okay, wow. There's a bunch of stuff here. I see why we need to generate something. So this looks like it's giving us all of our core libraries here, all the object files that it's going to link in here. Interesting. Okay, as part of the build here. So we do need to generate that. Interesting, instead of linking to like a runtime or having these libraries here. I think the reason for that, and we'll see if we get to that in the documentation, is just so you can do maybe a static build and just glue everything together. Sometimes it's kind of nice as a game programmer to just have things and statically link them together. So hopefully folks didn't leave when I was struggling with that, because this is actually kind of cool that we can have all these files here together and just link them together. I think that's actually quite nice here. Okay, this is just our program called test or whatever, which doesn't really do anything, but aha. Okay, so now we can write our hello world. Let's go back here. Let's do something with this here that's more interesting. Let's rotate that around here. Okay, and then we're going to remember 2 directories up, beef build, and then run is all I have to remember. Okay, so that's kind of nice. There's no real like command lines or anything to mess around with. Let's go ahead and do console.write. Oops, hit my caps lock. Right line. Hello, YouTube or whoever is out there. And this is a semicolon language here. There we go. So let's go ahead and save that. Oops. Let's see here. Delete. Okay, there we go. Beef run. And that does the recompile. Okay, pretty clean, pretty clean. Just had to wrestle with it for a few moments there. Let's go ahead and look at the language now. Some more of the cool stuff here. Here, let's expand this all the way. Okay, so these are our features. We got the space game, which we looked at previously. And from Beefy Tech here, the beef language. And we wanted to get to the forward here. which is over here. So we'll start with this. Let's get rid of all these different things here. And I'll put the links to the Hacker News article and the YouTube video, which I thought was neat here. But the overview here, let's get into it. So performance-oriented, statically compiled programming language, again, focusing on developer productivity. Again, I like that. It's pretty easy. I don't have to wrestle with any like things here, but I'm guessing with the IDE is how you get the true like nice experience. But again, that's kind of neat here. That things just sort of work. So again, high performance execution, no GCE or rough counted overhead. Garbage collection is actually, it's expensive if you have to collect, for sure. So I guess that just depends. As long as you're not collecting while major game code is running, that's fine. And again, rough counting overhead. Yeah, I guess with smart pointers. I guess Unreal Engine, I mean, has like UObject, which I think is rough counted, or maybe it's garbage collected. So it is kind of interesting to see the different philosophies about this. And I guess you could implement your own structures anyways for these. So minimal runtime, that's kind of nice, and compiled. So no JIT delays, meaning like if your game code's running and then there's a it finds like some code that's running enough that it's worth compiling, you can get a JIT delay where your game stutters, and while you're doing something interesting, it crashes or flickers and kind of ruins the experience. You don't generally like that. So you have a lot of control over your allocators and stack memory. That's kind of interesting. I wonder what it is here. And you prefer verbosity over conciseness when it aids clarity, readability, or discoverability. Okay, fair enough. Enable fluid iterative development. Okay, so we've got different ways to hot code swap and so on. I mean, I think these were a lot of things when we were looking at Lobster, for instance, with Wouter. You can see the interview, and then in the second half, we look at the Lobster language. These are like, again, languages built for game dev, so kind of cool to check out here. Maybe compare and contrast them. And again, it's built on top of LLVM, which is a fine infrastructure to build on top of. That's cool that they use thin LTO, that's link time optimization, which during link time, you have a view of your whole program so you can kind of optimize it, which is neat here. Okay, and the license was open source, as I understand, but here's the license here at this time. Let's again look at the language here. Compilation model. Okay, so this will help us understand what we were doing when we were creating a workspace. When we initially did this like generate new program here. So you have a workspace consisting of multiple projects. A project could be a library or could produce a binary, such as executable or a DLL, or I guess on Linux like a shared object or whatever. Okay, so that's kind of interesting here. Let's kind of keep moving. You can do things like incremental compilation, it was saying. So again, that's going to be super important. Safety features here. So let's see, you can have mixed sort of safety builds. So performance critical code can disable some checks, while less performance critical code can be annotated with more safety checks. That's kind of nice here. By default, you get all of these things enabled with debug builds. Yeah, like, again, D is one of the primary languages I use that has bound checking that stops a lot of errors. So I like this. This is kind of cool that you can actually do unchecked. Oh, interesting. Interesting. So that's how you put the like annotation, and I guess that's the attribute or something. And then I guess for this code here, okay, so you have like function level annotations or even maybe instruction level annotations, which is kind of cool. If you know how LLVM works, this is basically like compiler attributes and like metadata that you can attach to like instruction level, function level things. So I guess that's how they're doing things here, which is kind of cool. Let's see, dynamic cache checking. So explicit object casts to, okay, so that's kind of neat. I like explicit object casts, so again, that you don't have to, one, you can see them, you can grep for them. You can build tooling around those explicit checks, which is kind of nice without having to like parse the entire language. So you got memory leaks and some ways to avoid, I guess there must be some sort of leak checker or, maybe they're using like sanitizers or something to catch some of these memory errors from LLVM. Let's see what else we got here. Memory allocation can be placed on the stack, the global allocator, or custom allocator. Okay, so stack allocation uses the scope keyword, which can specify a scope from the current scope, i.e. code block, to the scope of the whole method, even a loop. Okay, let's see an example of this. This is kind of interesting. Okay, so here we've got a scope here for this guy, our string list. Scope of this string is the whole method. Oh, interesting. Scope colon colon. Interesting here. I guess that's because you don't want to keep reallocating this line string or something. So you're saying, hey, just allocate this whenever you create this so you don't have to do this every iteration of the loop. That would make sense. I mean, you could also, I mean, in practice, I guess it's just lifting up this declaration outside of the loop, maybe. Let's see here. I guess the syntax here I don't understand quite yet, but I could, again, imagine how you're doing this in a compiler. That makes sense. Okay, let's see. The scope of this string is the sort scope. Oh, I see. So you have like labels or something where you can set the scope. I see. This is just like an empty namespace, so it just means the whole like method, I guess, or whatever the top level thing is. That's kind of interesting. And this scope is just like maybe local or something. Okay, interesting. Okay, that's very interesting. Let's see. Allocations to the global allocator use the new keyword. Okay, so like most programming languages, you have a global memory allocator. And then, of course, you can do a new custom allocator. Yeah, that's kind of clean here. I like this. And this is why it's kind of neat to look at some different programming languages in different domains, because this is teaching us that, like, hey, like, in games, it's obviously really important to have lots of different type of allocators, like custom stack allocators. Maybe we have like a double-ended stack allocator, a global allocator, an allocator for like specific types of objects. So you kind of want like a pool of things, which is kind of neat. So that's kind of neat anyways. Let's see here. Minimum custom allocator must implement only a single alloc method. But a method can be added to add type-specific allocation logic. Memory is freed through a free method. Okay. Yeah, so you can add free. I mean, in theory, right, the simplest allocator you can have is one that's like a bump allocator that just keeps allocating memory, never frees. So that's kind of neat. And that is something that you could have in a game here. So you only need alloc, which is cool. Okay, and this is cool. So for a specific type, you can do things. Okay, that's pretty powerful stuff here. Okay, custom allocators can also allocate mix-ins. I love mix-ins. Got to see if it's working the same way as I understand them in D, though. Okay. So you got a lot of like really powerful features here. We'll get to writing some code in a little bit, but in a game or a game engine, right, having control over these things is how you get a lot of performance, right? Let's look at this. Just going to kind of skip around here again. Let's find some of the pretty shots. This is just showing like the shadows and the lights here. Optimizing for Switch, so they must have used beef for like Nintendo stuff here. But again, this is like really pretty. You can see some of like the shadows and stuff in real time. There's a lot of animations and all sorts of stuff going on here. So these are the types of things, if you have very dynamic things going on, like loading different chunks of geometry in a game world that are really big and expensive, and maybe you want to be able to free or release resources, you can be able to do that, or have control of that, even if it is on like a level by level or loading screen too. So very cool. Okay, let's see what else we got here. I want to kind of look at the language a little bit. So namespaces. Okay, so you got your like classic namespace here that you can sort of set up here. I like that. And then you could reference them by using. Okay, so this is very like C#-esque, as is the influence of the language here. Okay, let's go into some of the data types. Okay, so you got your types here with their width, so how many bits they've got. That's very nice here. I'm assuming int and uint just take the platform native size. Yep, that's what it is here. Cool. Doubles and floats, some char types, valueless, boolean types. We've got structs here. Let's see, structs are user-defined types, user-defined collections of values similar to structs in C. Structs can contain fields, properties, methods, and can define other inner types. For C++ programmers, structs are C++ pods and cannot contain virtual methods or copy constructors. Yeah, this is like the D language as well, where they're value types. So that's pretty close. And I don't. Let's see here. Now in D, you can have a copy constructor. I think you can define one, which is fine, but then it's not a plain old data structure or pod type piece of data. That's the other type of thing that pod stands for. And as long as you have a pod without like copy constructors and virtual methods and stuff, then I guess you can trivially copy it, right, with just like a mem copy or something. So that's probably why you would want this type of thing here. Let's see here, default constructor. Although if you have like pointers, I guess I gotta think about it. Then you kind of need a deep copy of some sort. So I guess you just can't do that, right? They just have to be like containers of data, which again makes sense. That's probably what you want to do again in game programming, right? Just have structs with plain old data. All right, interesting. And it looks like, I wonder if the data is immutable by default here. Let's see. So once it's assigned here, because I've seen this mute keyword for mutability. Method of structs need to be declared as mute to be able to modify the struct. Oh, okay, cool. So const by default. Again, probably the right default these days in languages. You kind of want to be able to flip that and just do that mutable. This is kind of a nice, clean way to do it, the way that you'd put const on something in C++ to make it read-only and control the access. So that's kind of nice here. Let's see here. Oh, interesting. You can't have structs that are 0-sized here. C++ doesn't allow that. Okay, yeah, and you have less alignment holes. Fields are ordered by field alignment size and subordered by declaration order. Structs. Okay, I guess that gives it a normal size here. I wonder, does that mean it's reordering things? I mean, you should order things in the optimal way so you don't have padding. Let's see here. Size and struct stride are separate concepts in B4C. Struct side is always aligned to the largest element. That's the equivalent stride in C. Okay, interesting. So I wonder how that works. Okay, oh, structs can be marked for full C interop with C representation. I see. Yeah, that's something. I mean, you either got to choose to align with C because, you know, most of our code needs to talk with C libraries, or have like some other strategy here, which it looks like, you know, there are some decisions about how to align things, which is kind of interesting. Okay, so yeah, in Beef you kind of go for the minimum size, which again makes sense for games. Now if you have 14 bytes, you're probably still padding 2 somewhere, probably. If somebody knows for sure, I should check on different architectures, but have to think about that in the code gen, because sometimes it's more expensive to do something weird like send 13 bytes somewhere, right? You usually like power of 2 things, but again, maybe different processors process things in different ways to make that as efficient, maybe. But typically powers of 2 is what we like. So that's kind of interesting if you don't use the C representation. But from the space performance, again, if in a game, if you're allocating, you know, thousands and thousands or tens of thousands of these like 14 byte things, you end up saving a lot of memory, which might be well worth the trade-off. So that's kind of cool. Let's see what else we got here. Auto constructors provide a shorthand for simple data types. Yeah, for this struct, you just sort of want these here. In D, we call these struct literals, which just lets you do, you basically get all of your constructors for free, minus, and then you don't have a constructor for like no parameters, right? It's just the initial values of the types. Now this is kind of cool here. You get tuple types. So I like this equals tuple. So this is a really nice way to just create some tuples here. Some math functions. Okay, cool. Okay, for the classes, you've got your like, yeah, pretty similar to like, again, C#. It looks like that's what the influence is, because you can have your abstract classes. I actually just like that because that's how a lot of the text literature defines things. Abstract is fine. I see interface in some places, which is also fine. So that's okay. Let's keep going on here. Arrays. Several forms of arrays. It looked like briefly. Okay, so here's 1D, 2D sized arrays, and you could do different sizes. Fixed size arrays. Oh, what is this? Question mark. I guess it just figures it out here. That's 2. And let inferred size. I see. Yeah, that's just inferring the size. I kind of like that. actually, that's something I would steal in this language here, just having the question mark and saying like, yeah, fill it in for me, whatever the size is. But I want this to be a static size, which is kind of nice here. I like that. It's very explicit and searchable, which is nice. Let's see, we've got enums, like in many languages. You can set some different types here. Cool. Okay. And then we can do a switch on the enums here. Now, this is going to get us into the pattern matching, maybe. Okay, well, we got a bunch of different stuff here. And then you have the type aliases. Cool. Okay, we've got interfaces. So let's kind of keep going through here. We're about 45 minutes in, so I want to look at some of the other stuff. Statements. Okay, defer is the one I want to highlight. If you haven't seen the like Odin video or Go or VLang, I think, which also had this, maybe a few other languages that I'm missing here, but defer will basically push these commands as you defer them onto a stack and then execute them later. So sometimes folks will use these if you have like something like create some object, and then you'll put defer, destroy the object, so that'll be destroyed. This is how you get your RAII stuff in C++, like resource acquisition is initialization. So that's kind of neat here. Cool. Okay, and then you've got like delete, do, for loops. Let's take a quick look here. Get your for loops, for loops, for loops. Yep, so nice ways to iterate through these collections here, or ranges, as we saw earlier. And yeah, this is using like the C++, or excuse me, C# style, where you're like get enumerator. So I can see while they're doing this. Yeah, so you have like this nice pattern with a while loop. While get next in the case is okay. Yeah, that's kind of neat here. And then you can remove stuff. Okay. And then dispose, I guess, to update, or maybe that's to destroy and get this object ready for garbage collection. I'll actually have to look at that, but there is no garbage collection here. So again, it's been a while since I've done my C#. I gotta look at dispose. Okay, and of course you can iterate by reference instead of value here, so you don't have to recreate copies of objects. That's good here. Common mistake, this will not change the values. Yeah, because we're not passing things by ref. Okay, interesting. Let's keep moving on here to expressions. Let's get into some of the other more interesting stuff here. Oh, okay, now interesting, actually. Bind. Okay, for method binding. If you want to build some other expression. Okay, you just use the equals greater than sign here. Method references. Okay, so this is getting into function pointers. Let's look at some of the more advanced features here. Now, box. Let's see. I wonder if this is more Rust influenced. I feel like that's where I see the box keyword. But we did our Rust preview a long time ago. Or Rust first impression. Scope, box, X, boxes, X in current scope. Oh, I see. Yeah. These are just scoping rules. Yeah. Okay. Yeah, that's neat. All right, let's get into some of the stuff. Interop. Okay, so we could talk to different libraries here pretty easily. Okay, so we've got our way to like statically bring in some of this code here. Yeah, the trick is you want to be able to bring in stuff with the correct calling convention and mangling. In C++, the names get mangled, so you gotta resolve that. And it looks like there's some techniques for doing that. That's all I'm really gonna say, and it looks like there's a way to translate from one type to the other, and they give some guide here. Yeah, Beef is a new language, so you have to sort of match the C stuff here. That's okay. Let's look at generics. So you got your generics, which were looking like they did in C# here. So some, again, pretty neat stuff here. This is all looking pretty good to me. Let's see here. Let's take a little look here. Generics. Okay, so you can specialize them as well. So, okay, this is just like your basic example. A new int or whatever. Let's see what's going on here. What is this where t? Oh, I see. Yeah, this is like concepts in C++ or template constraints in D, where you're saying, okay, you can put in any type here, but where the type is one of these things or satisfies these conditions, right? It needs to be comparable or whatever the interface is for op negatable. So if you don't have like a negation operation or something, you can't just put in any type here, right? Because it wouldn't make sense for absolute value. And these are really nice. I'm actually a fan of this as a library writer. If you're just implementing code, you might say, well, what's the point of this? But again, if you're writing reusable functions or libraries, you kind of want to define a strong interface that protects a user from making errors or misusing that interface. Because once they misuse it, then they've got to rely on that functionality. That's something called Hiram's law, where if later you come in and say, well, actually I want to add in a constraint or remove a constraint here or something, you got to be really careful about that. But if you start with no constraints at all, then people are going to assume you can just take the absolute value of anything, like a string or something, where it might not make sense to put a negative sign in front of it. So that's kind of interesting here. So yeah, that's looks like nice generics here. Let's get into the pattern matching stuff, because this is a little bit more of a hot topic here. And let's see what they got here. So pattern matching allows us for either simple equality checks or for creating a combination of member equality checks, member captures, and member ignores for tuples and enum values and switches. Okay, so let's see what we got here. Tuple case expression. Okay, so I got this tuple here with two things here. And it's nice that we could just sort of create this. Okay, so if the tuple case icy, so this is the tuple pattern matching for both of these here. So basically anywhere where it has 1.2, or you just take and consume the string value. Okay. Tuple switch. Here's another tuple switch. The case 0, 0. Draw at origin this string here. And then otherwise your case where you have anything else here. Okay, so I guess this is the like default case. Yeah, that's pretty clean. Oh, that's pretty nice. And it's nice that you can match against the whole tuple, I guess. That makes it pretty clean here. Let's see, enum pattern matching. Okay, so this is the type of thing where you classically get the examples. Let's see, we got shapes, rectangles, and circles. Let's see, we want to match against these. So if I have a shape here, okay, so match against here. Then I match against my other circle case here for any position or radius versus the ones that I want to draw at the origin. Or then any other shape here. Where I just say X and Y, and then I draw it, and then I don't care. I can discard what it is for the radius. Okay, interesting. Or it's not specified, maybe, then I just treat it as a point. Okay, I mean, you've got your general pattern matching, which is generally a nicer way to handle these if conditions, and usually you can get better error messages. We'll have to try a few more examples out, I guess. Okay, we spent most of our time just looking at the language here. I do want to get into the reflection and comptime stuff, though. Maybe we'll just run a few examples. Okay, so reflect here. Okay, Beef supports runtime reflection, so we can access and enumerate our fields at runtime. Okay, so we can just get the flag here, or search for the flag, which is kind of cool. Yeah, I mean, these are just really nice things to have. Most languages, what you end up doing if you only have like the static reflection is you kind of build up some data structure at compile time for languages that have good compile time programming. So that means like in C, you use a macro system. Languages like D, which have pretty good static reflection, where you can do stuff with like traits, or C++, you can do traits to kind of gather data about some sort of type and store it somewhere. That's also kind of fine. Let's see what's here though. Reflected construction. Values can be created from reflection information. Yeah, so let's see here. Can we create a new type here? I guess we're able to create new types here, which is kind of cool. And I wonder if that is stored in like some sort of language runtime. That would be kind of interesting. But then we use the object. So that's kind of cool. So a lot of questions here, and getting me curious about the language development here. Let's see. Oh, this is kind of cool. We can get some scriptable attributes. Let's see here. This attribute will show up, I gotta make this a little bit smaller, in the user's reflection information, and users of this attribute will have all their users' methods reflection information exported. Okay. Interesting, because I'm saying if it's a class or a struct, reflect attributes and get the methods here. That's kind of cool. So we can get all these things and see what methods we're calling. Yeah, this is a nice example actually of where the reflection is kind of useful to, you know, invoke a bunch of methods and just like test them out. This is super useful if you're like building a test suite or something. You just want to call every method. or log something for error reporting. So some cool stuff here with the reflection. Nice examples here. I mean, this is like real code that I can imagine the authors of Beef were doing in game programming. And then we're like, yeah, let's just integrate this in the language because it's so common. And you don't want to hack together like different systems for different projects. You just want to have it available. Okay, let's take a look at the comp time, and then I'll go back to the homepage and run a few examples. Let's see. So Beef offers compile time features which can be used to execute code which values to constant values or to generate code. So I'm guessing, yeah, things that are like static. Okay, they're using a static keyword to compute the factorial. And the important part is that this just looks like regular normal code. Right? There's no like weird template metaprogramming stuff. It's just defined as static, so it looks like it can just give you a value. And then as long as you're storing it, yeah, in some constant memory or something, it can, upon initialization, store it. So that's pretty cool. Call attribute forces comp time evaluation. Oh, interesting. It's forcing it. So I guess it's going to maybe give you a runtime error if that doesn't work. Let's see. I don't know how I'm going to force this, but we can... Let's paste some of this in here. Let's see, this is going to be part of our class program. And let's just pop this in here. Okay, so first let's see if it runs, if I just did anything weird. Okay, I did do something weird with the comments. And method factorial does not exist at line 14. I think it does exist. Let's get rid of the comments in case I did something weird. Let's see here. Let's see. Okay, I've got this function here. Let's run it again here. Method factorial does not exist at line 14. Oh, I see. I gotta do, yeah, put it in like my main or something probably. Right, we don't want to do like weird stuff. Oh, maybe, let's see. The variable fact is assigned, but its value is never used. Okay, interesting. That's a warning. The variable fact 2 is assigned. Okay, now it's working here. Okay. Interesting. Now, I need to think about how to write out these values at comp time, but it is working, which is kind of cool. And I can imagine how this is working. I wonder... So this is kind of interesting because, right, this is a const value, which I'm assuming the compiler just like infers, and it's like, yeah, we can figure this out. This is not a const value or anything. This is like a regular variable, and we're saying, hey, I want just factorial 2, and I might change this value later, but at least initially I want to force the compiler to evaluate this at compile time. I actually like that as an attribute. One, because again, it's searchable. And two, it means I don't have to have a bunch of like const variables and stuff. I mean, I guess I am storing this somewhere. I wonder how the compiler is handling this. I mean, is it just making this a static variable anyways? That's kind of interesting because the compiler and like LLVM is going to be smart enough to do like constant sub-expression elimination of things that are constant, just try to like figure it out, which makes sense when you have things like this pattern. But this, I guess, forces the evaluation and then maybe makes it static for you. I don't know. That's kind of interesting. That's very interesting to think about here. So comp time and then const value equals true. Hey, that's kind of neat. Because you would kind of want to set this equal to like true or false or something. And if you don't want, I don't know, maybe you could put a variable here or something. But if you don't want it to always just take a million years to compile stuff because you're doing a bunch of compile time evaluation, you could just have a flag that turns that to false. That's kind of neat. So there's some really well thought out stuff here in the Beef language here. I mean, we covered a good chunk of it. I guess we got to get into the IDE on Windows, which would show like the profiling and hot compiling and stuff and debugging. Okay, so we got some debugging tools here. We got a profiler, a sampler profile that's built in. I like that. And hot compiling, so we can just like swap in, you know, various functionality here. Pretty cool language overall. Glad we kind of, I kind of just, again, stumbled upon it in this Digital Foundries video. Again, just showing you more of this project you can check out. Looks like a super fun game as well. We should at least write one little, like, range or something. Let's just write a little, like, for let I in 10 to 20. Again, just getting kind of a feel of the language here. Some of the other things we didn't look at. Console.WriteLine. And then it's got, oh, the string interpolation stuff. Yep. What should I like here? That's pretty clean. Let's go ahead and, okay, we got that wrapped. There we go. Okay, so let's write another program that does something here. Oh, compile failed. What did I do here? Probably off on parentheses or something. Console.WriteLine. $, I guess, indicates string interpolation. Let's see how the error messages are. Oh, 10. Let I in 10 to 20 here. Type. Okay, interesting. System.object must contain a get enumerator method. I'm assuming 10 to... Oh, there's 3 dots there. I see. Okay. Let's see that. That's just a little mistake from other languages that I've used here, but there's our values. Okay, cool. We made it through that example. Not bad. Mix-ins for handling variables. Yeah, template mix-ins here, like in D here. Sorry, let's make that a little bit bigger for you. Yeah, basically this allows me to use this sort of as a template here and just pop in this expression, which is really, really neat here for this function with A, B, and C. This is the kind of stuff I love checking out. Super, super powerful. We looked at the compile time function evaluation, compile time code generation, which is neat. Oh, cool. You can just emit. Yeah, so you can literally like create functions and stuff and emit interfaces. In languages like D, you just have string mix-in, so you can do this sort of like emitting code if you want by inferring stuff from the different traits. But this is pretty clean here. I kind of like that it's compiler.emit. That's kind of neat here. Because I guess you could probably do stuff with a type, the interface. Yeah, this is pretty cool here. And add your like constraints as you go. So if you wanted to have like a specification or something, generate code for something that you're like hot reloading and then doing reflection on, you can do all that kind of neat stuff here. That's pretty powerful. So anyways, folks, I think I'm going to just end it there with the Beef programming language. Really neat programming language. It's cool to see like a, commercial game that is, I don't know, AA or AAA quality, let's say, that looks really nice. Again, I'll just, kind of keep flipping through this with real like tools and debugging stuff, which is really cool. And again, just looks really, really nice. So thanks to Digital Foundry for checking that out. Thanks for the developers of this project. Evening Star that's developed this game for just, in many ways being brave and showing what a new programming language can do that's, not mainstream and taking a risk here. I think that's really cool, and they built an exciting product. So I'm actually going to be checking that out and maybe, buying that on Steam or, giving it a try, because there's a demo on Steam that you can check out for Windows, which is really cool. So anyways, folks, let me know what you think about the Beef programming language. It's got a funny name. I guess we didn't find the source of the name here. Again, I do see a cow here. But anyways, I think that's it's got a really modern feel to it in some of the features that are available. It looks like it's a productive language. I'd love to try out the IDE on Windows. That's probably how you get the best developer experience. But overall, it seems to be a really, really well thought out language for its particular domain, and I'm sure it could be used to other domains. So be curious to see what the development is of this project in the future. Again, it's open source, so it sounds like folks can kind of mess and play around with it. It looks like it's been quite actively developed. I mean, the GitHub was being updated days ago, weeks ago, and so on. So it looks like an active and fun language to try out. So let me know what you think about it. Let me know if you built it for Linux or Mac or some other platform or even Windows from source, and how that experience was. I think once we got it figured out, it was really, really nice and fun to play around with. So anyways, folks, let me know your thoughts in the discussion below. I'd be really, really curious. And as always, thanks for your time and attention with this series, and I'll look forward to seeing you in the next one.